Hello folks, and welcome to the channel, or welcome back. And in this video we're going to tune the SU carburetor. The video is broken up in different segments, so you can skip to whatever segment you like. First of all, we're going to talk about the prerequisites before you start tuning. Then we're going to look at the carburetor itself, the baseline, as that is a good starting point to start tuning. We're going to get the carburetor ready to be tuned. And then we're going to talk about needles and power curves and the magic 3-point triangle, power, environmental, and efficiency. And then we're going to mount the HIF or the KIF 38 or 44 onto the Mini. We're going to do some testing at idle and under load, and you'll see all the different tools we're going to use to tune the carburetor. I'm going to be using more expensive tools. I'm going to be using very cheap tools, and I'm going to be using almost no tools. I'm going to try to show you the different methods on how you can do it. So without any further ado, let's start. The prerequisites, probably the most important part before you start tuning. It doesn't make sense to start tuning your carburetor if your engine is not in a tip-top condition. That means that all your cylinders should have the proper compression. And the difference between the cylinders should be no more than about 7 psi or half a bar. That should be the maximum. If that is not achievable, don't bother tuning your carburetor, because you're not going to get the expected results. Make sure that your valve timing is correct. And maybe you have installed a fast cam, so now you need to dial in your valve timing. Make sure that your valve clearance is set correctly. Then make sure that your ignition system is in good working condition and that your advance is set properly. If you have all those fulfilled, then you can start thinking of tuning your carburetor. Now, tuning a carburetor is all about matching up the carburetor to the purpose you want to use the car for. Maybe you want to use it as more efficient, so lower cost on fuel consumption. Maybe you want to get more power, and maybe you're just a very green person and you like to have low emissions on your car. These are different tuning profiles you can apply, and we'll look at those very shortly. So when your car rolled off the production line, it was tuned. In other words, the carburetor was adjusted to a proper balance between power, fuel consumption, and maybe emissions. Now that actually came a lot later, but depending on the age of your classic car, it may have that last part on emissions as well. So it's a balance between those 3 points. And therefore, the SU carburetors are what we call baselined. And a baseline carburetor is the right starting point for you to start tuning the car. Once you have identified the baseline of your carburetor, then it's time to start looking at the parts that wear out on your carburetor. There are parts on the carburetor that actually might need to be replaced. The parts that are subject to wear and tear is actually the piston into the dashpot. So therefore you need to do a drop test. The damper may be worn out. Check the damper. But also the jet may be worn out. And the needle, especially on a KIF and a HIF carburetor. And then finally, you might want to check actually the needle valve, because that could be worn out and the float. So all these things need to be verified. So before we start tuning, you have to make sure that your carburetor is absolutely baselined. Now, baselining is all about making sure that all the parts in the carburetor, the springs, the dampers, the float, the needles, the jets, that all of that is according to the specifications when your car rolled off the production line. That's the best starting point to start tuning. And check my video on baselining. In this part here, we're going to reassemble my carburetor, and we're going to look at the parts that we're going to replace. Now note that I have already done the HIF 44, which is on my right hand side, and in front of me I have the HIF 38, and that's the one I'm going to put back together. That's the one that was originally on the Mini. That's the one where we did the AFR test with. I have actually cleaned the HIF 38 in an ultrasonic bath. I took it completely apart and I did an inspection. And the reason for that is that I didn't know the state of the carburetor. Now, if your carburetor, of course, has a known state, you have cleaned it yourself before, or it's brand new for that matter, then you don't need to take that step. But I had to, because this was an old carburetor with an unknown state, and luckily that I did, because there were quite a lot of things that were polluted and wrong with this carburetor. So I'm going to replace on this carburetor the needle valve, And here you have the old and the new one, and I'm going to replace the jet with a new jet. And this jet I'm going to put in is a 0.09 inch jet. In the HIP 44, it's a 0.1 inch jet. So depending on the carburetor, depending on the specifications for your specific engine, you may have to choose a different jet. And then of course I'm going to put in a new needle. And I need to explain something on the needle, why you need to change the jet and the needle, because that is very specific to a HIP 44 or a HIP 38 or a KIF carburetor. And the needle in the HIP and the KIF carburetors is spring-loaded. See how that can move. And it's been pushed against the side which is facing towards the engine side. And there is a good reason for that. And that, of course, is now causing that needle to rub against one side of the jet. So while this piston is moving up and down, we're going to get friction on the needle and we're going to get friction on one side of the jet. And that's why we need to replace this about every 25,000 miles or about 50 to 60,000 kilometers. That's the time you should actually change the needle and the jet in a HIP or KIF carburetor. So the spring-loaded needle, or also called a bias needle, was done for very specific purposes. Emission control rules become more tight over time, and the SU carburetors with a fixed needle, so a centralized needle, had a bit of an issue with a constant and accurate fuel metering. And that, of course, is a bit of an issue for emission control regulations. So SU had to change their design, and they found that if they're using a bias needle, which is leaning towards one side of the jet, they had a far more constant fuel metering. So that was something they had to do for emission control purposes. At the same time, they also added another element into the HIP and KIF carburetor, and it probably is now the right time to mention this. This is a bimetal. It sits in the fuel chamber, and what it does is it actually moves the jet up and down a little bit depending on the temperature of the fuel. And we all know that fuel will behave a little bit different under different fuel temperature conditions. So these are modifications that were done on the SU carburetors really for emission control regulations. So now I'm going to reassemble the carburetor, install all the new seals and gaskets, the new needle, the new jet and all that. It doesn't really matter if you're going to rebuild your carburetor first and then tune, or you can start tuning right away. You're going to need X amount of parts, either to rebuild the carburetor or actually to tune it. So I have a set of needles here. This is mandatory to have, and these needles all have different curves. So if you're going to tune, make sure you have a set of needles, and for that you need to figure out what needles you might think you need. They are not very expensive. I also got a set of springs, and these springs, that's a spring right here, they come in different colors, and the different colors indicate different loads. So the purpose of the spring is to prevent the piston going all the way on the top, to give it some pushback. So if your piston is going all the way to the top too soon or too fast, then you might have to put stronger springs in or softer springs, depending a bit on the situation. Now, of course, the damper plays an important role as well, so you may get a different damper, and you can get all these parts from a good store in the UK, and I'm going to put the name up below. I'm not making a commercial for them, by the way, but they have all the right original parts. So go for original parts. It's important because a carburetor is a precise instrument. You may also need some new jet sets, and this is a jet set. So I'm going to replace the jet, and you will see why we need to do this on a HIF. And then, of course, you have all kind of seals and gaskets and so on, and you got the needle valve. So all depending if your carburetor was rebuilt already or not, you're going to need more or less parts. But as a minimum, you're going to need a couple of springs, and you're going to need a couple of needles. And you're going to need some reference material like a needle chart and spare parts and specifications catalogs to identify exactly what you should and should not order. We finished up rebuilding both carburetors, the 44 and the 38. Now the 38 was the original carburetor that was on the Mini. So I'm going to put this one back, and also going to put back the 44. And the reason I'm going to put back, first of all, the 44 is because the intake manifold that I have on my Mini is actually a modified one. It's a stage 2 engine that I have, so the opening on my intake manifold is actually 44 and not 38. So if I put the 38 up, I'm going to lose some of that efficiency on the opening. But nevertheless, we'll mount the 38 as well, and we're going to tune the 38 as we're going to tune the 44. Now, there's a few more points I want to make clear. So once we start tuning, there's a couple of things that we will be looking at. We will be looking at the piston movement. You know, how high does it go up while the car is on the load? We will probably be playing with the spring, the load of the springs, if necessary. And we're going to try different needles. I have here 4 different needles with different curves for the AFR. We need to look at a graph very soon on how that affects the power on the engine, and I want to take you through that practical session first, so there's a good understanding the difference between the needles, but also the difference between vacuum and RPMs and vacuum and load. Because there's a misconception out there. People think often that RPMs determine the vacuum inside the carburetor, and that is not entirely true. The carburetor, when fitted to the engine, is having right between the engine and the carburetor a throttle, right? This is the butterfly that you see, that butterfly right here. And that actually shields off the carburetor from the engine when you're running idle, because that butterfly is closed. So although the engine is running at idle, maybe 800 or 1000 RPMs, there is very little vacuum coming into the carburetor. Even if you're now increasing the idle speed maybe to 2000 RPM, you're going to open up this butterfly partially. Not full, but partially, just a little bit. But if you were to go uphill with the same RPMs, and depending on the angle or the steepness of the hill, you will see that your gas throttle might even be wide open. And I'm sure if you're driven on a very steep hill and you were going in 5th or 4th gear, you had your gas throttle wide open, and still the car wouldn't make it, so you had to shift down. So what that shows is that the load determines the vacuum in the carburetor, because the load will determine the position of the butterfly to maintain a certain speed, of course, and a certain power level. So that's very important to remember. So let us now have a look on the actual curves and a bit more about power. Now, before we do that, I just want to go back to one more thing. Remember the 3 points we were referring to? We had efficiency, we had power, and then we had the environment. Well, again, if you're going to tune the carburetor, make sure that you know for what point you're going to tune. You want to go more towards the efficiency, so less fuel consumption. Then your engine is going to run a lot hotter. And if the engine runs hot or too hot, then you're going to have a far more higher amount of NOx gases, not good for the environment. And in fact, running lean means running hot. It's not that good for the engine either. On the other hand, if you want to get more power out of your engine, then you're going to burn more fuel, so your AFR is going to go down. But if you do so, then you're going to consume more gas or fuel. So that is a bit of the negative side of that. And again, if you go too far in the power level, which means the mixture is rich, you may get problems with your spark plugs because they may become really clogged up and dark. So that's not good either. So you have to find that balance. And maybe you're more into the environment, to protect the environment from harmful gases or exhaust gases. Well, then you can't go really efficient. You can't go real power. You have to take somewhere the middle road, and then you try to stay around the chemical correct value for the AFR, which is something like 14.7 to 1, which is the stoichiometric value for traditional gasoline. So enough of all that. So now let's look on the graphs, and we do some more talking on that one. If you have watched the baseline video, that you know that we were using a needle profile chart, and I actually mapped all the values of the needles that I have here, these are the needles in front of me, into a graph so you can see the effect of the different needles on AFR. So let me open up that application and then I'm going to show it to you. Needles have different stages or areas on the needle, so every 1/8 of an inch you have a new station, and this is 1, 2, 3, 4, 5, 6 and so on, and you can see that station 1 is all the way here on the top of the needle. When the piston is all the way down into the jet, that's the thickest part, and while the piston moves up, the needle moves up and we get smaller diameters of the needle. Now it all depends a bit of what needle we're looking at, a 0.09 or a 0.1 or 3/16 of an inch. There are different needles for different carburetors, but that's in essence what it is. So I have different needles right here, and I plotted them out in a plot, and you can see that in the radar view in a few minutes, and you will now be able to refer back to the actual stations, what they mean. So if the piston is all the way up, then that's where the station will be. That's the kind of area of the needle that will be in the jet, so very thin. So we get far more richer mixture. And by playing with different needles of different thicknesses, you can actually affect the air-fuel ratio and actually the power on the car. And that's what tuning is all about with needles. So the curve that you see on the screen is an AFR, air-fuel ratio, versus the maximum power that your engine can develop with a specific air-to-fuel ratio. The blue line is your air-fuel ratio. The red line is your power curve. So 20.00 for AFR means 20 parts of air, 1 part of fuel, will develop 30% of the maximum power of your engine. If you go to the extreme right, and we would have like 8 parts of air and 1 part of fuel, so running very rich, then the power that can be developed by the engine is something like 92%. And of course, between the two extremes, we have different values. Now, we all know that the chemical correct mixture, or the stoichiometric value, is 14.7 parts of air versus 1 part of fuel. And that will develop around 95% of engine power. Now, most cars don't run very well on idle or takeover with 14.7. Most of us will have to adjust it a little bit more rich, and typically 13.2 is kind of the sweet spot for most cars, and that allows you to develop 98% of your power. On the other hand, if we go in uphill or we need to accelerate, we're going to need a bit more power. So we'll have to make the mixture more rich, and as you see on the curve, the red curve, we can reach about 100% of the power of the engine when the mixture is around 12 parts of air to 1 part of fuel. So we're running fairly rich. However, once you are on a highway, for instance, and you're starting to cruise, there is no need to maintain this rich mixture. We can drop back down. In fact, we can drop back down to the chemical correct mixture value, and hereby actually saving fuel. And that's all what there is to a power curve. So we can now play with this power curve, as you see here, and we can play with the AFR by adjusting the needles in the SU carburetor. So now let us look on a needle curve. So don't be thrown off by what you see here on the screen. This is just a representation of the needles. I've got 4 needles. ADP, AG, AEM, and AEJ, and they have different colors. So the blue one is the AEJ, And you can see that blue line going around like this. And all what that is showing the diameter of the needle, how that changes. And because I have 4 different needles, they have different diameters. And the smaller the diameter becomes, and this is the diameter, the figures 0.9 to 0.1, so the smaller that becomes, the more fuel can get out of the jet. So the richer the needle is, as we say. So you know that needles have 16 stations. So the first station is when the needle is all the way down, so that we run like running on idle. So that's station number 1. And when the piston moves up like this, it's going to be lifted up a bit, station number 2, then we go to station number 3, and so on. So every station is about 1/8 of an inch, so of lift of the needle. So there are 16 stages in total for that needle. So if the needle is all the way on the top, so the piston is completely upwards, then it's we are at station 16, and then the needle, for instance the blue one, will have this thickness, which is something like 4.8. So I've mapped it for all needles so you can actually see what the difference is. So initially we will be running it on an ADP needle, which is this one right here. And if you look, they all start at the same thickness. They stay together, but then they start breaking up a bit, especially here at around station number 7. But the ADP needle stays a bit thick, I would say. See that? This is the one right here. So even at station 12, it's sitting a bit lean. So the more outward in the circle, the more leaner things are. The more inward the curve is, the richer the mixture will be. And you can see that, and then at the end we are back to the closed position. And I've done it for all the needles, and there is little difference between them, except the AEM needle, which is having a smaller opening on the jet, so richer mixture at station 8. So this is almost like kind of mid-range, and that is because that needle is typically used for an automatic. And I think that's where normally the engine is shifting, the gearbox is shifting. So I think that's why they made it a bit more rich. So the needle I'm aiming at, but it isn't fitted yet, is the AEJ. And if you follow the blue line, it stays the same, but at one moment in time it's going to part from the rest. And at station 8, so like halfway the piston being lifted, it's going to increase the mixture quite a bit, and it's going to keep on increasing it until station 16. And in station 16 we're going to be running far more rich, and this is wide open, and that's what I wanted to have. So this is how you should plot your needles, and to see exactly what you need. So hopefully that didn't scare you off too much, but these are the basic things you're going to need once you start tuning, because you will have to select the right needle. Now, of course, the question is, how do you know what needle to select? Well, that is actually through test rides. So either you do a test ride and you feel how the car behaves. If you have the right measurement tools, then you can look on your AFR gauge, for instance, like I have in my Mini, so I can see what my AFR does. We looked on the power curve, so I know more or less where I should be. But of course, you don't need to have an AFR gauge. You can just feel your guts feeling, and if you accelerate and you feel that the car doesn't accelerate fast enough, it's hesitant, then maybe there's an issue with the actual needle. You have to have a richer needle, or maybe the piston isn't working right, or the damper is not the right one, or the oil is not right in the damper. But for that, you will have to have a look actually under load on your piston, and that's not always easy while you're driving the car. So you might need an action cam, which is actually filming your actual piston while it's moving up or down, so you can analyze exactly what's happening, and you know at that moment in time what you need to do with your carburetor. If the piston isn't able to move up at all, then maybe you have the wrong damper oil, maybe the oil is too thick, or the spring is too strong. So these are all things you need to look at, and then do the analysis, and then try to fix that with other parts. And that's why I'm getting different needles, that's why I'm getting different springs. So this is a little bit of testing and exercising. The next thing we're going to do is to install the HIP 44 and adjust it for idle running. We'll do this by adjusting the idle mixture screw on the side, And we already have pre-adjusted the carburetor. And remember the pre-adjustment, if you don't know how to do that, have a look on my baselining video. But in essence, you put the jet level with the bridge of the carburetor, and then you turn 2 full turns clockwise, and that's your basic setting. We'll then use 4 methods to adjust this carburetor, and I'm going to show that to you depending on what tools you have available. I'm going to set it probably to about 13.4, 13.2 AFR with my AFR dial, if you have one. If you don't have an AFR dial in your car, then you can use what we call color tune. It's a little tool, and I'll show you what that is. It's more or less correct, and I'm also going to show it you with a gas analyzer, a very cheap gas analyzer, but that works as well. And then the 4th method is by using just an RPM meter and playing with it around that top curve, as you've seen. So you're going to crank it up, adjust the screw until you have your maximum RPM, you readjust your idle RPM, and then you can turn back that screw a little bit until you have that tipping point there. And that typically is your best idle setting for your car. So let us go downstairs and do it.